the interest of time, I'm not going to go into a lot of details. Dr. Roshan Rajapaksha is a very experienced software engineer, as you have seen in the blurb that I have posted in the announcement, and he's one of our own PhD graduates and has been doing research in this area, DevOps, continuous software engineering. And he has also been helping me in running SPI for the last 2 years, and he has done such a good job. That is why he's continuing with us for the third time in a row. So we are, in a way, we are privileged to have you, thousands of miles away. He's currently in Sri Lanka, but you can learn from his wisdom, and he has a lot of interesting insights to share. Over to you, thank Roshan.
Thank you, and thank you for the opportunity to contribute to the course. And this is, of course, my research area. So so I did like Amali mentioned. So I completed my PhD recently, 2023. So that was I mean, the research was mainly on continuous software engineering and software security. And one of the key focuses was on how we can, um, use software practices, in particular continuous practices, which I'll be talking a little bit today, and how do we, balance the security versus speed, problem in these workflows. So I'll touch a bit on that, but my key focus is on, presenting some of these continuous practices, because the course is software process improvement. And I think you can also use some of these processes in your project. So let me, so title is Paradigm Shift in Continuous Software Engineering. So basically, I'll be trying to speak on these topics, continuous software engineering, and then I'll talk about three specific continuous practices, and the way that you can, set this up in a Git-based environment. And I'll probably talk a little bit about the DevOps and DevSecOps, the security integration within the DevOps paradigm, which is, the new paradigm, DevSecOps. And so I'll take some questions and, go from there. Right. So one of the main things that I mean, in this industry, you get a lot of buzzwords, right? Everything. I mean, there's a lot of stuff coming up in the industry, right? There's new tools, various processes being introduced, and sometimes it'll be a bit, as students, sometimes the terminologies might be a bit confusing, which was the case for me also when I started. So you get methods, this is the paradigm shift. There's frameworks, there's processes, there's practices. I mean, when you're stepping into the software processes area, I think one of the main things that you have to do is to differentiate these terms. At least, I mean, there's no wide agreement, but at least you'll have to have your own, not own, I mean, at least a sense of what these terms mean broadly, so that you can digest the content in this area. So, I mean, if you look at these terms, sometimes you see, for example, uh, Agile versus Scrum, and how things like DevOps, the word paradigm, how those fit into the overall picture. So, I mean, there are certain terms that I don't even agree. So, for example, DevOps engineer is a like a job role these days. I'll explain why that is a bit tricky. So let me, because I mean, ideally, I would have liked to, get your feedback on what you think is the proper usage of these terms. For example, what is the difference between Agile and Scrum in this particular case? So, but since it's a short lectures, I'll directly dive in to my interpretation. So we can you can question this if you do not agree. So if we break this down into layers, the broader layer, the first layer would be the term paradigm. So, and when you take the word paradigm, so you can take the definition of that term in the broader sense, not in the software engineering sense. So in paradigm, generally it's a mindset, it's a philosophy, or it's a set of ideas that you would guide you in doing something. So in the context of software engineering, so it's a mindset set of ideas that would guide how you can go about in software development. So in this particular in our context, so I would clearly see that agile would be one instance of that. So, if you look at Agile, so it's this. So if you see the image in the right, that's the Agile Manifesto. So you can just Google Agile Manifesto, and you'll arrive at this web page, and it'll give you these kind of pointers like individuals and interactions over processes and tools, working software over comprehensive documentation, and the other two, customer collaboration and responding to change. So this is broadly what agile means. So saying agile as agile methodology would be a bit tricky because it doesn't prescribe specific practices or specific workflows. So that kind of thing is not actually prescribed within the Agile Manifesto. So, I mean, but with Scrum, what you find is you'll find specific artifacts, you'll find specific processes, you'll find specific workflows that actually aligns with the ideas of the Agile Manifesto. So what I'll go about, how I would go about this would be Agile would be the paradigm or the mindset, and Scrum would be a specific methodology that actually follows Agile. So, this is the same case with DevOps. I'll explain this with some examples. I'll go, in the next set of slides, will be giving you some examples for this in terms of my own projects. And I'll also show that DevOps is also strongly falling into this paradigm bracket. And so things like Scrum, Waterfall, and XP. So these would be specific methods that actually follow certain ideas that is pitched in these paradigms. So paradigm was a method. So I would try to differentiate these two things. And then the other thing is another layer down would be the processes and practices. So that is, these would be specific processes and specific practices like continuous practices. So they can be like a method can have multiple such processes and practices include within that specific overall method. So this would be my a way of breaking it down. So I've gone with the conceptual definition of what that word means, and then I've applied to these software engineering concepts. But some might disagree with this, I suppose. And so this is why for example, this is why find it a bit difficult to digest the DevOps engineer role, because if you can see, it's here I've tagged DevOps as a paradigm, a mindset, or philosophy. So an engineer in a mindset would be a very tricky thing. So generally when we say DevOps engineer, it's the continuous practices, the CI/CD part, and the ops part that is kind of expected, but the role is tagged as DevOps engineer. So yeah, so I'll give you some examples first. So if you take the paradigm shift, so I think you were fairly you know I think you are fairly aware of the broader paradigms or the broader methods that I'm mentioning here. So we started with waterfall. So I mean the clear, I mean I mean it's the emphasis there was on the linear sequential approach. Um, and it made sense when actually waterfall was the dominant method. It made sense because initially software development was broadly in the defense and the government based projects, and it made sense at that particular time because they wanted the documentation. They wanted, if for example in defense kind of software engineering projects, they wanted that structured approach, the sign off, that kind of thing, and it made sense. So it was suited for well and clear stable requirements. But when actually software engineering became a bit more mainstream, so the shift was from software being very specific usage for governments and defense industries into the business domain, where it became a bit more widespread. And the problem there was, I think you are fairly familiar with this, the problem with the unclear requirements. So the clients or the customers found it a bit hard to, state all the requirements at the start of the project, or there are unclear requirements when the project was actually in the initial phases. So this is where the agile philosophy came into the picture. Like if you take the agile manifesto, the points that is mentioned there is catered toward this. So it's catered towards prioritizing the customer and introducing a bit of flexibility into the process. So I want to emphasize that in the industry, whenever there's a paradigm shift, it's always because it's always driven from the customer's side. It's always driven from the user's side. So in this particular case, it was driven from the inability of the users or customers, particularly in these business softwares, to define uh, the complete set of requirements at the start of the project. So this is why we had to shift from waterfall to the agile approach. But this is not to say that waterfall is bad. This is to say that in cases where there's a bit of difficulty with defining requirements up front, the agile way of doing this would be the better approach. So in my experience, so the initial set of projects that I undertook as a developer was purely waterfall, and because they were a bit, they had the involvement of the government, and so we had to do these specific documents. So we started with a document called the ASIS document. So that's the what you call the existing process flows, and we had to clearly document them. And then we created another document called the to be document, like the business blueprint is what we called it. And this was the re-engineered process that we proposed to to be implemented using the software. So all of these documents had to be signed off and approved before we start the development processes and all that. And I mean, that project itself, I mean, it worked quite well. So this is, I mean, sometimes waterfall method takes some, hit based on, inflexibility, but in certain cases, it is actually the way to go. So, I mean, so even though we say that, okay, agile gives you the flexibility, sometimes it's the waterfall method that makes sense based on the context. So in agile, some of the projects that I've done was based on this interdisciplinary kind of work. So I worked in another software where we developed a facial reconstruction system. I've added a small image there. So this is where we get the skull, like the skeletal remains, and then take a 3D scan and then reconstruct the face based on certain variables like the skin tissue thickness and the other facial component analysis based inputs. So in that particular case, it's a bit of a research driven project, and we had to change the development workflow and the requirements based on the research that was, being done in parallel. And so in that particular case, it was very hard for the medical the medical party to define all the requirements in a very specific way at the start of the project. So in that particular case, agile actually made sense, the iterative and incremental approach. So this was based on we first started with some prototypes, and we started with the proof of concept kind of thing, and then had that proof of concept as the baseline, and then added the other modules on top of other proof of concept, based on the demonstrations and based on the input that we received from the medical students. So in that particular case, agile way of thinking, so it's Scrum that we use, but the overall paradigm that guided our work was agile, and it made quite a lot of sense in that project. So now, if you can recall, from agile waterfall to agile, the shift was the flexibility. So the handling of unclear requirements. So, but with time, agile or the Scrum uh, kind of methods also was not sufficient to deliver another specific requirement the customers or the businesses had during that time, and that was rapid deployment. That was continuous deployment. So with the business environment getting more, competitive and challenging, and with new competitors coming every day, so the next business requirement or the user requirement was that they wanted, or the customers wanted to have a method or a set of practices where they could develop software components or transfer code from a development environment to a production environment in a very continuous and rapid cycle. So this is where the continuous practices came into the picture. So continuous integration, the practice continuous integration is what came first. So I'll explain. So this will be the next section of my talk. So I'll explain to you the CI/CD, the continuous integration, continuous delivery, and continuous deployment, the three key development focused continuous practices, and how you can implement them maybe in your project. But the key thing there was automation. So the requirement was, how do you actually transfer code that is there in the development environment in a very rapid manner, or in a continuous manner, from the development environment across QA and staging environments into production environment. So that was broadly what was driving this continuous software engineering movement. So if you take this term, continuous software engineering, is kind of like a umbrella term. It has multiple continuous practices included or captured within that term. And so the focus of, so what I'll try to cover is the development focus continuous practices, which are the CI/CD and CDE. I mean, sometimes we call this the CI/CD pipeline, and setting up pipelines. And so I'll briefly explain that. And so that worked quite well for one of the logistics products that we have done. And the reason for that was we had multiple change requests, multiple updates, feature requests coming very frequent basis. So we had to have the CI/CD pipeline set up in that project so that the customer could get the changes done very quickly from the development environment to the production environment to the live environment. And the next shift, so I mean, if you take all of these things, there's one key thing driving that paradigm. So in waterfall, linear, sequential, agile, it's iterative and incremental, with the focus of requirement flexibility. And in continuous software engineering, automation. Automation is the key thing, and that supported continuous cycles. And then we come to the next shift. So in continuous software engineering, so if you look at the software engineering environment, you would know that it involves certain set of roles. Like you have the developer who does the development kind of work, developer related work, and then you have the quality QA teams who is engaged in the testing, the quality assurance, and then you'll have the operations and the maintenance teams who would maintain the servers and then monitor the production environment. And the problem was that when they were setting up and when they were proposing these continuous practices, um, practically when you were trying to do that, like if you take continuous deployment, so in continuous deployment, what happens is the code that is updated in the development environment directly hits production environment. So it directly gets transferred to the custom. So in that particular case, you would see that the changes that the developer does has to go through all the activities that traditionally the QA and ops teams were doing. They have to go through them and then go to production environment across that workflow, right? So in that particular case, the problem was that the traditional team-based, like functional team-based working environment was not supporting the implementation of this CI/CD, these practices. And this is, if you look at this in a practical sense, this has to be obvious also. So developers work in their own functional teams. That's the development team, and the QA team has their own functional alignment. That is to develop, that is to test the software. And when you take the security team, they have their own functional alignment. That's to produce secure software. And the maintenance or the operations teams, so their focus is on how to have a stable production environment so that any changes won't break the build. But here, when you get the continuous practices, that the focus there is how do you produce software and produce features or do changes to the main code base in a very rapid way. But since the traditional functional way of software development actually didn't support that way of software development, and this is where DevOps came into the picture. So purely, so this is my PhD area also. So I'm quite strong in this opinion also. So in DevOps, the key thing is collaboration, the collaborative environment, setting up the collaborative environment where you remove the silos between these functional teams. And the purpose of that is to enable these rapid cycles of continuous practices. And that collaboration is what DevOps tried to introduce. So if you take the term DevOps also, so it's development operations. So that is the two terms that they have combined into DevOps. So there, the key thing is collaboration. How do you set up and remove these silos between these two teams so that they can engage in these continuous practices? And if you go back to my first slide, so this is again aligning with what I said. So collaboration and removing these silos, this is a mindset, right? This is a culture, this is a cultural shift of teams being transferred from the functional way of software development into a more collaborative working environment. So, I mean, with that said, could you see the term DevOps engineer? So that would be a bit tricky, right? Okay, how do you have somebody managing the mindset, like the engineer who's managing that mindset? Purely the DevOps paradigm's intention was to have that paradigm shift or the cultural shift in working. So, but in currently, if you search Seek, there'll be DevOps engineer being advertised a lot. It's used quite frequently. But if you check the job roles, you'll mostly see most of the stuff that is mentioned would fall into what is already available in the continuous practices. So setting up the pipeline, setting up the ops, setting up the ops environment, and that kind of thing. So that was already there in the CI/CD, which actually came before DevOps, and DevOps came a bit later. And so this is a key thing that I wanted to highlight today. So I mean, you could also read some of this content and some of this work and some of the manifestos and all that by yourself, and try to see whether what term or what phrasing would most suit when you're actually talking about these things. And this would give you a bit more clarity in terms of doing these things in your own own project. Okay, so now I hope the paradigm shift is I made my point across with the paradigm shift point. And the next point is that even though we actually have these well-defined methods like Scrum and methodologies like Waterfall, in my experience in the industry, rarely does a company or project follow a specific method or methodology in its defined workflow, and it's always a mix of stuff that I've seen in industry. For example, I mean, even if it's waterfall, in a lot of the projects, even within the overall broader workflow of the waterfall cycle, we had some of the agile related ideas being implemented. So, for example, in the second flow, overall flow is workflow, but you have the build and test automation, and that is somewhat related to the CI practice also. In CI, I'll explain CI in the next slide. So the 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 situation in practice is that you can learn all of this conceptual stuff, like the theoretical stuff. You have to know that, of course, but when you get into the industry, you'll see that it's always a mix. It's always a mix of these things applied in a way that is driven from the customer's requirement, driven from the conditions where you or the team members' requirements. And this image is actually something that I took from the internet, and it shows various configurations of the DevOps and waterfall and agile based principle being mixed in the overall workflow, so that it's not pure waterfall, or it's not pure Scrum, it's not pure agile. I mean, for example, the current project I'm doing, it's broadly waterfall, but we have the Scrum based cycles in the development phase. So the requirements are signed off. So I mean, broadly, I would say this is a waterfall based project. But the way that we handle the development work is based on the Scrum-based cycles. We have the daily stand-up, and we do the development work in cycles and the sprint cycles. But that is purely within the development space, and the overall project is handled in the waterfall stages. So, a good example of how it is usually they're done in the industry. Yeah, so in continuous software engineering, like I mentioned, so this is umbrella term, and it's this paper that actually used like the umbrella term continuous software engineering, and then they gave a kind of a classification on how the continuous practices could be categorized into certain areas. So they did three categories: business and strategy, development, and then operations. So what I'll do is I'll cover the development practices, which is what I'll think, or I would think that you would find useful at this stage of your project. So you'll have I'll share the slides, and so you can have a look at this paper to get a overall sense of what continuous software engineering is. Yeah. Okay, continuous integration. Now, in waterfall, when we were working in a waterfall based, you know, workflows, generally, there was a well-defined, there had to be a very well-defined scope of work before the development work was commenced, like was starting, and then that actually supported uh, a very uh, good definition of this individual scope of a developer. So you would know that software is rarely built by one person in the industry in large scale projects. There's a whole lot of people who would be engaged in the development process. So in waterfall, because of the inflexibility or because of the requirement, because of the requirement of having a certain set of established features well defined in that particular workflow, dividing this work across developers was a bit easier. But with these agile-based methods, with these Scrum or DevOps or CI, like the continuous software engineering being more widespread, this work division or very well-defined scope for one developer became a bit hard. And in this case, there were multiple people working on the same set of kind of like functions, features, and all that. And continuous integration actually came into the picture to support this kind of environment, and particularly cases where distributed software development and software developers were working across various locations, various places, and doing the changes. So in that particular case, one of the main problems that they had was whenever there was more than one person like changing a certain section of the code, like if they are work. So typically what happens is, I hope you know the typical Git based workflow. So they'll have the shared, or they'll have a development copy, like their shared main line of the code base, and they'll most possibly clone or pull the code base into their own laptops, and then own working environment, and then they will use their own IDEs to change the code in their local environment, and to work on the feature request or the bug fixes or whatever. And then they would push, or they would try to merge that work after a certain period. And the typical practice was that in waterfall-based methods, this merging of work happened after a lengthy time period, because it was there was a very specific scope for the developers to work on, and the merge was encouraged after that scope or after that particular feature or bug fix was completed. And the merge was the merge in that particular case was to have a substantial improvement, or like a bug fix or a feature improvement to deliver to the customer. But within the current practices, the problem was that whenever there were multiple people working on this, you would see that. Now if you take this example, now if you take developer 1 and developer 2, let's say developer 1 worked on these code lines, and I mean, this is a very simple example, and the developer 2 worked on a same method, same function, but a different area. And then they try to merge this work after, let's say, 1 to 2 weeks, and you would clearly see that there would be merge conflict, because I mean, even though they have worked on different, like let's say they worked on different functionalities, the different aspects, when they, I mean, because of things like this, because of conflicts and conflicting code segments, the merge of that work into the shared or development mainline would not go through because of a lot of these conflicts. And what happened during this 2014 time period where software development was becoming mainstream and the distributed way of software development also was becoming mainstream. Such merge issues, such conflicts became widespread. So, and the problem was that, I mean, because the practice those days was like to merge after a certain time period, finding the particular area of the code where this conflict happened also was a problematic, because they were changing a lot of code during that period. And because it's a lengthy period, and the problem is that sometimes it was very consuming to pinpoint where the merge conflict occurred, and this became an issue those days. So this is where practices like continuous integration came into the picture. So in continuous integration, the first best practice is that best practice number one, frequently integrate code changes into the shared repository. So the practice here is that whenever you do a change and you do this change in your own local copy, as a practice, try to frequently integrate these changes with the shared repo. So this is now my typical workflow would be I start my work at the start of the day. I pull the shared repo. I see the feature requests. I see the bug fixes that I'm assigned. Then I have a breakdown of, in my mind, I have a breakdown of, okay, my first commit or my first change would be this this set of codes, this set of functions. So the set of function that I combine into a commit also makes like logical sense, like they are related. But I as a practice at least try to commit if I'm working the whole day on that particular issue or that particular feature request. I at least try to commit at least 4 times. So there's no rule here. So the best practice here is frequently integrate code changes. So I mean, people, if you search various resources, they'll give you certain practices. I've seen, um, resources and guidelines like mentioning 10 to 15 times per day also. But I mean, that depends on what you're doing. So as a practice, what I usually do is at least 2 or 4 times a day that I try to merge the logical set of changes that I could capture within a commit, and I commit that frequent into the shared code base. So in that particular case, what happens is, so let's take the same example. So developer one, let's say, now this is simplified, of course. So let's say developer one worked on this particular change first. Yeah, this is just changing of the parameter, and then let's say they worked on that, and they first pulled the shared repo, worked on this, and then pushed it back. And then developer two, who's going to work in another function, pulls that code, which is already pushed by the first developer, and the change is already there because this is pushed into the shared development branch, and she gets to then have those changes within her local copy when she's doing her changes. And she also then does her changes, and if commits it back to the shared development repository. So does this mean that this would always avoid merge conflicts? No. That is, of course, not the case. Sometimes, even within this kind of workflow, there would be merge conflicts. But the point is that because we are actually merging small or short and small segments of the code, finding that particular merge conflict is much more easier. So this is the first best practice. Frequently integrate your code changes into the shared repo. Have a shared repository first. So in your projects, what you can do is you can first select the project. I'll give you some pointers if we have time on selecting the open source project in this course. So I see a certain set of questions. Mali also mentioned that there are certain questions on how to select this repo. So I'll try to give some pointers on that also. But as a practice, what you can do is you can select, after you select that the repo, you can fork it into your own account. Like you can have a shared repo kind of thing, and then whenever when you have divided the work across your team members, like the development workload, you can clone or you can pull the code from the shared repo, do the changes, and then merge it, like frequently merge the code back that you're working on with very descriptive, like if you're committing the code into the repo, another best practice is that you have a descriptive commit message saying, okay, what is this change? What did you do with that particular commit? So it gives other team members also some help, in terms of, understanding what you have done in the code base. So making the fork from the repo and having that fork as a shared repo, and then having a workflow where everybody would have in a shared repo that the changes are being pushed to, and whenever people are working on their own feature or on bug fix, they're going to pull the code, do a small set of changes, push it back, save, see whether there's any merge conflict, and then proceed from there. So best practice 1, frequent integration. Okay, so best practice 2. Now, this is also continuous integration. So when we say continuous integration, it's just not one thing. It's a combination of stuff. So in this case, so when a whole bunch of people were, um, checking the code in. So what happened was that after continuous integration and this frequent code merge was actually pushed as a mainstream practice, the next problem was that, so you have to build the code, right? You have to build the code to make it a running software. So in this particular case, what happened was that the frequent changes, when the people were like, the developers were frequently changing the code base, the compilation errors like building errors became issue, and then this practice itself introduced a certain set of bugs because a lot of people were changing small sections of the code in a frequent way. So to manage this problem, what they introduced was to have a build and testing engine, like a CI tool, to manage the CI process. So here what happens is, I'll give you some examples for these tools. So you have the workflow that I mentioned before, and you do that with a testing or CI tool integrated into your GitHub or your Git-based workflow. So a typical function of a build and testing engine or CI tool in this environment would be, whenever a code change happens, like whenever there's a commit or whenever something hits the shared dev repo or branch, this tool would automatically pick up the code, would build the code, would test it. So this test you have to actually define within the tool. These tests can be some integration tests or some of the tests that you would traditionally do after the code is merged into the branch. So that's up to you. Typically, this would be certain set of integration tests, and if there's a particular issue, this is directly notified to the relevant developer when the code is when the person or he or she is trying to merge that code into development branch. So the tool would not allow the code to be merged into the development branch or the shared branch if there's any conflict, if there's any build issues, or if any of these tests are not passed. So CI introduced the way of frequently changing code. This brought the problem of bugs and the compilation errors because a lot of people were changing it a lot of times. To fix that problem, they brought in CI engine, CI/CD tools, and the solution there was to automate the build and testing process and test the code that is continuously integrated into the development or shared branch in automated way. So you can, of course, have a look at these tools. So I've used a lot. I mean, this is Jenkins is the old school tool. So this was something that was very popular. It's the old school CI tool, dominant tool some time back. So now there's a lot of tools coming up. So I've recently worked with Travis CI and found it very good. But the tool that I recommend to you is this one. So this is not essentially a CI tool. This is called a workflow tool, GitHub Actions. So what it does is this. Now, when I say CI/CD, I'm of course describing a particular way of uh, doing software development, right? So we loosely call this a workflow. So GitHub Actions is a workflow automation tool. So it works in the workflow scripts, YML scripts. So I think, do you have a script here? Yeah. So this is a script. I use ChatGPT to generate this sample workflow with GitHub Actions. So you can very easily integrate GitHub Actions into your Git-based environment because it's the same. I mean, it's from GitHub. You would not get any compatibility issues, and using a script, you can define how you run your workflow. Like if you have let's say you want to have a different CI tool like Travis integrated into your environment, you can clearly integrate that into your workflow and then write the script in a way that whenever there's a code change or commit made to the main branch, you can trigger a separate or third-party tool and then run the test. So everything related to the workflow is defined in this script. And whenever the tool picks up certain changes, whenever the tool picks up there's new things going on with like it can be a pull request. So the way that you define this is based on your requirement. Sometimes you can do it whenever there's a pull request or whenever there's a code change, like a commit. You can define this. So this is I in my prompt I said write a GitHub Actions workflow for the Node.js kind of project, and then it'll give you the workflow. So here in doing CI, I mentioned that you have to define certain things, like you have to define certain tests, and you can define, okay, what is the tool that you're going to use. So all of these things you can do using a GitHub Actions or workflow automation tool. Okay, so how am I doing the time? Okay, I'm all, okay, what should I do? So, so I'll quickly finish up CD and the remaining two practices, which is what I wanted to cover today. So that is continuous integration that I mentioned. So the next practice is called continuous delivery. So in continuous delivery, what happens is that now you should, be aware of development occurring in different servers or different environments. So typically work that the developer does first hits the development environment, which is what I talked up to this point. So this is the CI part. So this is the CI server that I mentioned. So this can be any tool or that I mentioned before. So that tool would do the building and testing, and this would be within the continuous integration scope. If all of these things are passed, like the build is passed and test is passed, you can then deploy the code into the staging environment. And in certain cases, I've also seen a QA environment also here. And from the QA, there's a staging environment, a separate staging environment. But for simplicity, let's say the staging environment. And in this particular case, after you build the software, you have the running code, you have the running product after the changes are integrated. And these can be then deployed into a staging setup. And this is where you do the dynamic tests, like you can do fuzzing, you can do certain dynamic application security testing, DAST. So any test that needs the software to be run, you can do it in the staging environment. And the term continuous, the practice continuous delivery is where the process is automated from this point to this point. So this is where code is, these tests have been passed and the code is deployed to the staging environment. And in the staging environment, you have the dynamic test also defined within that script that I mentioned, or any other tool that you find suitable. And so these acceptance tests and performance tests and all that, all of them are also automated. And if they are passed, let's say all of these tests have also been passed, in continuous delivery, what happens is from the staging environment, so staging is typically an environment, a server that actually replicates the production environment setting. Somebody manually releases, checks the results of the test, checks whether everything is fine, and manually releases the code, the running product, running software from the staging environment into production environment. The only change between continuous delivery and continuous deployment is that this release is also automated in continuous deployment. So in continuous deployment, you define all of these tests in using tools and scripts, and provided that all of these have passed, code from the development environment directly hits the production environment and reaches the customer. So this is the only change with continuous delivery is that somebody manually releases from staging to production, and in continuous deployment, this is also so provided that all of these have passed, this is also released to production. So continuous deployment, setting up a continuous deployment pipeline is challenging. So if you can see, you have to automate a lot of things. You have to integrate a lot of tools into this environment, manage 3 different environments or 4 different environments. You have to define everything within scripts. And for that, you can use some of these workflow tools. But for your project, of course, I think setting up this continuous integration practice would be sufficient, because I mean you are not expected to change and have the production kind of setting being maintained, or you don't need to have the product in a production environment and do demonstration or something of that sort. You'll of course have to show the work that you do and how it affected, or how it affected the shared the open source repo. Like, so the best case scenario would be your changes are accepted by the repository maintainers into the mainline. So that's kind of like the best case scenario. So that is a validation of your work being accepted by the people who are maintaining the software. But what I wanted to do is to make you aware of these practices, because now some of these are becoming mainstream, like companies like Amazon, Facebook, and they are making changes frequently. Like, for example, Amazon, they are known to change the code base very frequently because they have a lot of products. Like I've seen in certain resources, they change the production environment up to 500 times a day. So in that particular case, you have to have a very strong pipeline with these practices set up in their own environment. Okay, so I think I've run out of time. So ideally, so I usually cover this in a 2-hour lecture. So I had to rush certain things. Yeah, so in DevOps, the key thing is that you have so typically code is the code and build part is done by developers. QA and staging is done by testing, and the ops part is the staging and production environment maintenance. So you could clearly see that to set this workflow up, there has to be very strong collaboration between these parties. And this is where DevOps came into the picture. So when security also became an issue, initially, the workflow was that when developers worked on a certain code base and they wanted to transfer the code into the QA or production environment, so what we did was we had a ticketing system. So we had to raise a ticket, and then this ticket was then approved. And then after the ticket was approved, it was when the code was transferred from this environment. And you could clearly see that this kind of workflow would not work with these continuous practices where rapid code deployment is needed. So this is exactly where DevOps actually came into the picture to have a continuous kind of workflow, a collaborative workflow with these parties. And this is DevOps. And when you take security also into the picture, so that is again now in DevOps, it's the two functional teams are developers and operators. And in DevSecOps, it's developers, operators, and the security team also being involved in this collaboration. So that is DevSecOps. So when you hear these terms like these buzzwords, DevOps and DevSecOps, the key thing that has to come to your mind is collaboration, the collaborative culture that supports these continuous processes. Yeah, I think I've run out of time. I was also going to prescribe kind of a workflow, but I don't think I have time for that, right? Yeah, it's run out of time. So what you can do is, so I'll have I'll have the slide set posted in the course page. I'll also have my email. So if you have any questions about setting this workflow up, like how do you set this up with a particular set of tools, if you want some recommendations with certain tools and certain workflows and certain advice to set this up. So I've studied this for 4 or 5 years. This was my PhD area, so I can give. This not doesn't say that I know everything. So this is a rapidly changing environment, but I can give you some advice on setting these things up. That's number one. And I also wanted to give you some pointers on the project selection, but I don't think I have time though. I I heard a lot of beeps of people leaving, so that is probably your lunch time, right? So yeah, so I'll speak to Dr. Amali and I'll try to see how I can give you some feedback on project selection. So this is, I mean, in this particular case, it's very hard to say, give it as a rule. Like, so people have asked how many issues that they want to tackle with the project. That's very hard to say because a issue within this space can be at least, sometimes the issue can be as simple as changing the label of a certain field. And in certain cases, the issue can be a major fix, major bug fix. So if you're doing something major, like a major set of additions to the code base, and that is actually captured as just one feature, like one issue in the code base, that would be sufficient. But in cases where the issue is actually very small in scope, like there's nothing much to do, in that particular case, you'll have to do a larger set of issues. So what we propose is I'll give you my contact details, and so you can reach out. So there's two layers for this. You'll anyway do a contribution proposal where you'll list out the project and list out the specific issues that you're going to work with in detail, and we'll give you the go-ahead kind of thing. So we'll have a look at the issues, and I'll go to the repo and the issue numbers, and I'll see whether there's sufficient scope to handle for this project. That's the first layer, and you can informally also reach out and send me the issue numbers and send me the issue URLs and see to get me have a look at those things, and then I can of course give you some feedback on whether it's suitable or not for the project. So yeah, so I think I've run out of time. Do you have any questions?